Yes, welcome. Good day, my friends at the mean your lecturer on chemistry. Dr. D.I. June is my name. We are still dwelling on the main topic, change of states. In my previous lecture, we discussed on evaporation. Right away, we will discuss about vapor pressure. Vapor pressure. See, I don't want to rush these things in a way because it is good that you understand before we go further. So I'll be reading what I have, then I will be explaining so that you get it well. Now look at it now. When an evaporating liquid is confined in a closed container, the escaped particles gradually accumulate in the space above the liquid. Can you see that? Now, if you are boiling water, for example, now water is in a pot, and you cover it, before the water even start boiling, if you open the cover at one time, you see already vapor coming up. And because the cover is there, they will come in contact with the cover and begin to condense. In short, because the water is confined, the liquid is confined in a pot or in a kettle, the vapor coming out will get contact with the cover. They'll get accumulated there. So here, the particles collide frequently with one another and with the walls of the container. And consequently, they will exert a pressure known as the vapor pressure. Now, when the particles or the molecules leave the surface of the liquid and they go to the vapor state and they are now in contact with the cover, they're not going out again. Because they are still in the gaseous state, the spaces are far apart. So the collision among them will increase. The frequency of collision will increase. And that is talk about the vapor pressure. Therefore, the vapor pressure of a liquid is a measure of its tendency to vaporize at any given temperature. In the course of their collision, some of the vapor molecules return to the liquid by condensation. Look at it here. Now, this is the liquid per se, the liquid particles. Now, when the heat is applied, the particles that will gain extra energy will begin to escape. So by evaporation, they go to form the vapor particles. They are now in the gaseous state. Now, in the gaseous state, if there is any cooling effect, which is called condensation, the particles will now come back to form liquid. So by evaporation, liquids in the surface, particles in the surface in the liquid surface will go to vapor. Then the vapor particles by condensation or cooling will come back to form the liquid. That is a circle. So condensation therefore increases as the vapor pressure rises up. So the vapor pressure continues to rise until a stage will be reached when the number of particles condensing into the liquid is equal to the number of particles evaporating from the liquid. I think this again, listen very carefully. That the vapor pressure continues to rise until what? A stage will be reached when the number of particles condensing into the liquid is equal to the particles that are what? Evaporating from the liquid. That is what we call the vapor pressure. Now, this condition in which the state of condensation equals to the rate of evaporation is called the state of equilibrium. I take it again. This condition, that means in which the state of condensation, that is vapor, cooling back to the liquid, and then the liquid vaporizing to form vapor particles. If these two processes are becoming equal, then it means an equilibrium is attained. That's what we're talking about. So at equilibrium, the vapor pressure stops rising and remains constant. Now see, at equilibrium, the vapor pressure will remain constant and will not increase anymore. This is called saturated vapor pressure of the liquid at that temperature per se. So the vapor pressure of a liquid depends on the temperature and also on the nature of the liquid. Now, what is happening here? If here to be water or kerosene or diesel or any other liquid, the period or the time taken for this process to take place may not be the same, because the nature of the liquid also determines the rate of the vapor pressure that will be formed per time. So, like it, comment, and share this video. Make it viral. And please remember to subscribe to my YouTube channel. God bless you.